Hello, nice to meet you. Today we are going to talk about heart automaticity. How can the heart beat by itself? We studied this phenomenon related to ion power. We have already studied heart rate related to ion ago by doing Physio X. But we couldn't check it out that how can the heart get the strength to beat by itself. This is why we chose this topic. First of all, let's see pacemakers located in heart. Pacemakers have priority to control heartbeats. SA node is the first pacemaker. If there is a problem that SA nodes don't make electric charge enough in heart, second, third, fourth, and fifth pacemaker will operate in order. This graph shows action potential of heart. This part with red box so it presents pacemaker potential. As you see, this is slow depolarization. I think you can understand the rest part of it. So, we will see 4 ions effect on heart automaticity. Sodium, potassium, calcium, magnesium ion. And we will check the differences between normal situation and situation with inhibitor. To this experiment, we need a heart of rabbit. I'm sorry for that after smashing rabbit's head. Take the hearts out from rabbit. And then put the heart in thyroid solution with 100% oxygen. After 1 hour, cut the heart vertically to crista terminalis. Then put it in the solution for 1 hour. In this case, the heart almost recovered its automaticity. After that, to measure voltage of cell membrane, insert glass microelectrode that has 15 milliohm resistance in cell. This picture shows where the crista terminalis is. First, we see an effect of extracellular sodium. As concentration of sodium decreased, the amplitude of action potential decreased and the cycle length was lengthened in Figure 1. At Figure 2, we can check effect of tetrodotoxin, which is inhibitor of sodium. In situation at TTX, the cycle length was slightly lengthened. Next, you can see effect of extracellular potassium ion on the action potential rabbit assay node at Figure 3. Experiments were done at 4 different potassium concentrations. According to increasing of concentration of extracellular potassium, size and time of action potential decreased. Also, maximum lag phase voltage and depolarization slope decreased. Frequency of spontaneous action potential was decreased and finally stopped in 24 millimole potassium. Figure 4 shows effect of barium ion, the potassium blocker. It increased the duration of action potential, but almost no change was noticed in the cycle length. You can also see calcium ion's effect on the action potential at Figure 5. As concentration of calcium ion increased, action potential and lag phase voltage increased, but duration of action potential was shortened. Figure 6 shows the difference between case that just added calcium ion and other case that added with cadmium, which is inhibitor of calcium ion. In the latter case, the cycle length and duration of action potential was lengthened. At last, Figure 7 shows magnesium ions case. Pacemaker cells membrane potential and maximum lag phase voltage didn't have significant correlation with magnesium concentration. Increasing of magnesium concentration slightly decreased action potential and lengthened cycle length. This is the experiment result about 4 ions' effects on heart automaticity. First, for change of extracellular sodium ion concentration, as sodium ion concentration decreased, size of action potential and the frequency was remarkably decreased. Maximum lag phase potential was unchanged, and frequency's action potential was largely decreased. With TTX, the blocker of sodium, action potential frequency decreased and action potential period slightly increased. In potassium ion's case, as potassium ion concentration increased, size and period of action potential was decreased. Maximum lag phase potential and slope of lag phase depolarization was decreased too. And with barium ion, the blocker of potassium, action potential period increased. When calcium ion concentration increased, action potential size and maximum relaxation period increased. And with cadmium, the blocker of calcium, action potential period slightly increased, but action potential frequency decreased. At last, when magnesium ion concentration increased, action potential size slightly decreased. With these results, we could learn about 4 different ions' effect on heart automaticity. Thanks for listening our presentation.